Hi, my name is Alison Hardy and I'm with the University of Texas at Austin. In this spiral video, I will be covering how you can tackle directive word problems in your classroom. First, I want to differentiate between routine word problems and directive word problems. In routine word problems, students must determine what information is unknown and how to solve for the unknown. In routine word problems, we can categorize them into 5 schemas: total, difference, change, equal groups, and set or comparison. Whereas with directive word problems, students are directed to complete a mathematical task, and these word problems cannot be categorized using those 5 schemas. So this is one example of a directive word problem. It says, Yolanda wrote a number. The digit in the millions place is an 8. The digit in the thousands place is a 6. The digit in the hundredths place is a 2. Which number could be the number Yolanda wrote? So in this directive word problem, students are being directed to determine which of these numbers has the following digits in these place value positions. Everything we do in Spiral can be tied back to our instructional platform. The components of our instructional platform are explicit instruction, vocabulary, multiple representations, fluency, and problem solving. So I'm going to walk you through how directive word problems relate to each of these components. First is explicit instruction. Well, directive word problems assess directly students' knowledge and skills, and high-quality explicit instruction is always going to be the first place to start. Within explicit instruction, we use this model from the National Center on Intensive Intervention: modeling, practice, and supports. Here we have an example of using planned examples to teach directive word problems. You see here that we have the stem and leaf plot from that directive word problem isolated, and then later on we add a little bit more context, and then here we situate that stem and leaf plot within the context of the word problem. So when we're teaching directive word problems, we want to think about starting with that content and then gradually making examples more complex until they're situated within contextual directive word problems. We also want to use step-by-step explanation. So for example, today we will solve word problems with graphs. First, we will write UPSCheck. Within guided practice and independent practice related to directive word problems, we want to make sure to incorporate multiple representations by using manipulatives. And I'll dig a little bit deeper into that within our third component. And lastly, we have our supports. We want to make sure to ask students a mixture of high-level and low-level questions. So for example, a low-level question could be, what is the value of the number if the stem is 3 and the leaf is 1? An example of a high-level question could be, explain what the problem is asking you to do. We also want to elicit frequent responses, and these responses don't always have to be oral. We can encourage our students to use nonverbal gestures to respond, or they can write or draw pictures. And lastly, we have providing affirmative and corrective feedback. So an example of affirmative feedback related to directive word problems could be, I noticed how you read the problem carefully. Reading the problem will help you understand what is being asked. An example of corrective feedback could be, I wonder if next time you could write out your plan before you start solving. Can you show me now? Our next component of our instructional platform is vocabulary, and directive word problems include numerous vocabulary terms. We want to prioritize building students' vocabulary knowledge so those precise mathematical terms don't throw students while they're trying to solve directive word problems. So let's look at this word problem as an example. It says a rectangle has a perimeter of 40 centimeters and an area of 64 square centimeters. Which model could represent this rectangle? So within this directive word problem, we can use 4 different spiral word wall cards to help support students in understanding this vocabulary. Next, we have multiple representations. Directive word problems often include visuals that students must interpret. So make sure that you're including multiple representations in your instruction to ensure that students are familiar with them. So here's one example. And this directive word problem says, the models represent the price for a pound of grapes at 4 different stores. Each model is shaded to represent a price that is greater than $1. Which stores have a price greater than $1.60 but less than $1.90 for a pound of grapes? And here, we can see that these models are a pictorial representation of a hundreds flat. So students will likely be more successful in solving this problem if they've had frequent experience with our concrete base 10 blocks, as well as the pictorial version of our hundreds flat here. So this is another example of a virtual manipulative where students are able to shade in grids on a virtual hundreds flat. So with this directive word problem, it's going to be really important that students have access to multiple representations of numbers and values. Next, we have fluency. Well, directive word problems can be very lengthy. And we know that fluency frees up working memory so that students can address these complex sentences. Let's look at this example. This directive word problem says Cassidy walks and bathes dogs. She charges $8.50 if a customer wants a dog bathed and walked. She charges $5.75 if a customer only wants a dog walked. The list shows the jobs Cassidy did last weekend. And here we have our list of jobs. Cassidy used the following expression to determine the amount of money she earned walking and bathing dogs last weekend. How much money did Cassidy earn walking and bathing dogs last weekend? In this directive word problem, students are simply being asked to solve the given expression. So if they have fluency with solving expressions and multiplying decimal numbers, then their work would look something like this. And if a student were to see this expression and think to themselves, I know how to solve expressions that look like this, I have so much practice doing so, they're not as likely to get so overwhelmed with the depth of context and reading that students are also expected to complete in this word problem. Lastly, we have our problem-solving component. So with directive word problems, we can also use our attack strategy, UPSCheck. Let's take a minute to unpack a directive word problem. So within this directive word problem that we saw earlier, we know that students must understand the terms perimeter, area, and model. Students must also be able to make sense of what the problem is directing them to do. This means they need to understand how to calculate the perimeter and area of these 4-sided shapes. Students must also eliminate incorrect answers and identify the correct model. So I encourage you to sit down and before you model for students how to solve a directive word problem, make sure that you're unpacking all of the knowledge and skills that are required to solve the problem. Now I'm going to model for you how you might teach students to solve a directive word problem using our attack strategy, UPSCheck. And anytime you see a speech bubble like this, I will be modeling how you can use think alouds to make all of your thinking transparent to students. So you might start by saying to students, first, I need to write UPSCheck. Now I need to understand by reading. A rectangle has a perimeter of 40 centimeters and an area of 64 square centimeters. Which model could represent this rectangle? I see 3 rectangles and 1 square. I know that to find the perimeter of those shapes, I need to add the lengths of the sides together. And to find the area, I need to multiply the length times the width of each model. So I need to figure out which of those models has a perimeter of 40 centimeters and an area of 64 square centimeters. I'm going to go ahead and underline those two pieces of information so I can refer back to it quickly. Now that I understand the problem, I can check off the U and move on to making a plan. I think the first thing I will do is figure out which of those models has a perimeter of 40 centimeters. And then I can figure out which model has an area of 64 square centimeters too. I'll make a note so I don't forget. Now I can check off the P and start solving. I'll start with rectangle F. I know that the opposite sides of rectangles and squares are equal in length. So if this side is 32 centimeters, then so is this one. And I'll go ahead and label the length of this side. And if this side is 2 centimeters, then so is this one. So to find the perimeter of rectangle F, I will need to add the lengths of all 4 sides. That means I'll solve 32 plus 32 plus 2 plus 2. And I know that 30 plus 30 equals 60, and 2 plus 2 plus 2 plus 2 equals 8. So the perimeter of rectangle F is 68 centimeters. The problem says that the model should have a perimeter of 40 centimeters, so rectangle F is not correct. Now I can cross it out and move on to the next model. So here you will continue the procedure. You will model for students how to find the perimeter of shape G by adding 8 plus 8 plus 8 plus 8, which equals 32. This is also not equal to a perimeter of 40 centimeters. So you would move on to shape H. 16 plus 16 plus 4 plus 4 does equal a perimeter of 40 centimeters. But you want to make sure to find the perimeter of shape J as well. 11 plus 11 plus 9 plus 9 also has a perimeter of 40 centimeters. So now you might say to students, now that I know that the correct model is either rectangle H or rectangle J, I need to figure out which of those rectangles has an area of 64 square centimeters. To find the area of rectangle H, I need to multiply the length times the width. So for shape H, I have 16 times 4, which leads me to a product of 64 square centimeters. The area of rectangle H is correct too. So rectangle H has a perimeter of 40 centimeters and an area of 64 square centimeters. But before I select my answer, I will find the area of rectangle J to be sure. 11 times 9 equals 99. So rectangle J does not have an area of 64 square centimeters, so it is not the correct model. I'll go ahead and cross that one out. So now I can circle my answer and check off the S for solve, but I'm not quite done yet. I still need to check my work. So I will calculate the perimeter and area of rectangle H one more time. The perimeter is definitely 40 centimeters. The area is definitely 64 square centimeters. So now that my answer is correct for sure, I can check off the check mark. So this was just one example for how you could model solving a directive word problem using our attack strategy UPSCheck. Lastly, we encourage you to spiral directive word problems. So that means you're going to want to find a way to embed directive word problems into each of your units. You might find a way to include them in all of your formative assessments. And I also want to remind you that you have spiral word problem sorting cards. And all of those cards that on the back say no schema, those are examples of directive word problems. So you should have 50 fourth grade directive word problem cards and 50 fifth grade directive word problem cards. But you can also head to our Spiral website to download printable directive word problems. And these word problems are identical to the no schema sorting cards, but students can cut these out potentially glue them in their math notebooks and solve them during small group instruction. So we hope you find this resource helpful to you as you spiral directive word problems throughout your year. Thank you, and we hope this content was helpful to you as you focus on directive word problems this year in Spiral. We look forward to seeing you in the next Spiral video.